There have been a number of questions about maximum rig weights, so I wanted to make a video going over the subject. To start, let's look at the weight of the rigs. They will vary a lot, but generally will fall between 60 and 120 kilograms. Add your weight to that and you have the total. The springs included in the kit can support up to 260 kilograms or 570 pounds. Now, we could have gone with spring rates of 1,000 pounds or more, so why stop at 570 pounds? To explain that, I want to go over a few basics. From a hardware standpoint, there are three components that dictate the quality of the feedback. They are the vibration isolators, the transducers, and the weight of the rig. Starting with the vibration isolators, their springs have a number of parameters like spring rate, deflection rate, natural frequency, but we figured that out, so you just have to make sure to use the lightest springs that won't bottom out. The kit has three sets of springs, and you want to use the ones that provide the least resistance to motion, and that means the lightest springs possible. They aren't for tuning the system in any other way. The remaining two components, the transducers and the rig weight, are especially interrelated. Remember that vibration is motion, and the heavier something is, the harder it is to move. Therefore, the more you increase the weight of the rig, the harder the transducers have to work to move it. Put another way, decreasing the weight of the rig is the same as increasing the power of the transducers. And here's why I like to keep the weight as low as possible. Transducers have a sweet spot at which they make the most power. For these transducers, it's in the 40 to 50 hertz range. Above and particularly below, the output drops off significantly. So if your rig is heavy, you'll be okay with the mid-range frequencies, but the effects in the lower frequencies will be weaker. Now, why are these lower frequencies important? Why not just set the frequencies where the transducers are most powerful? And you can do that. It's not a bad option, but there are two reasons I think it's better to have a broader range of frequencies. One is that a tire going over a rumble strip is generally a low frequency event. I mean, depending on car speed and the bump profile, I think it feels more realistic down in the 20 to 30 hertz range. And secondly, because the effects have more depth if you vary the frequencies. So I don't want to get into tuning in this video, but in general, I like to split the frequencies into three sections. The higher frequencies are for things like engine vibration, the strong mid-range for shifts, and the lower frequencies for the rumble strips on the curbs. And those curb effects are important because while the engine and the shifter sensations really bring your rig to life, the road rumble effects really bring the track to life. And I would say curbs are probably the most important part of the track. They define the limits of the track and they have a huge impact on the handling of the car. So depending on the corner, you might want to run over the curbs to widen the arc. You might want to stay off them because they unsettle the car, or the paint reduces the grip, or you might want to just use a part of the curb to rotate the car. And because of that, you want as much feedback as possible on how you're hitting the curbs and how they're affecting the handling of the car, which means that road feedback is not just immersive, but it's also informative. So I want to make sure everyone can set their system up to feel these effects, because I think sensing that feedback and the direction of its source is the best part of the system. Additionally, some effects can be set as a priority. The software does this by cutting off non-prioritized effects during or whenever prioritized effects are activated. And heavier rigs require higher transducer settings, and these cutoffs are more noticeable at higher settings. It's similar to coming off the throttle in a car at high RPMs versus low RPMs. The former is just much more abrupt and noticeable. So reducing the weight reduces the settings, minimizes these cutoffs. Now, if you're at the upper end of the weight limit, what can you do? One, you can obviously turn the system up. I think it's always good, though, to leave a bit of headroom. It's less stress on the parts of the system. And so if you do turn it up to the higher levels, pay attention to the heat of the components or any protective cutoffs that are kicking in. Number two, you can run all your effects in the transducer's more efficient mid-range. This is not a bad compromise. As you get the road feedback, it's still good. You just don't get quite as much depth and variation. And three, you can lighten your rig wherever possible. If there's anything you can remove, like if you have your computer or your monitors or what have you, or if there's anything you can swap out, like a heavier seat for a lighter one, I recommend doing that. You have to think of your rig as a race car. It's the whole add lightness thing. And if you get these elements sorted, if you get your rig as light as you can, and you get a good tune, which by the way, I'll be creating some tuning videos, and there are tunes at the bottom of the tuning page on the website. If you get those things sorted, it'll bring your rig to life, it'll bring the track to life, and it really adds a whole other dimension to your racing. So it's worth getting those details right. It's just like car setup, only it's rig setup. So hopefully that clarifies the effect of weight on tactile feedback. If there's any questions, post them below and I'll do my best to answer them. Thanks very much.